A very good morning, students. We are in our practical lecture, and this will be lecture number 5. And today we will try to solve map number 8. And the question is a thin coal seam having a dip of 2 degrees 6 minutes and a direction is say south 35 west, outcrops at point P. Trace the outcrop, describe the topography of the area, comment on the trend of the outcrop. And the left hand side you can see here is the map with the northern arrow in the top corner, and the scale is say 1 centimeter is equal to 200 meter, and here is the contours, and the outcrop point P is in here, right? So this is the question, and then we have to solve this question. And as you know, we have solved two questions like this in the same way, by connecting the equal value of strike and contour, right? But the only difference here is that the dip direction, which is say south 35 west. In our previous case, we had deal with north 35 east, right? So here in this case, it is south 35 west. That is, the dip is in this regional slope direction, almost nearly the same direction, right? Okay, so let us solve it in the same way. But for the first thing, what we have to do is we have to use the two set squares and mark the northern direction in this map for our reference. So just marking it in the map with the help of two set square and mention it as N to indicate it is a reference line for the northern arrow. And the next step is that we have to point out the dip direction. For that, we can use the protractor in here, and the direction is say south 35 west. So this is north, so this will be east, and this will be south and west. So from south towards west, it is 35 degree. So here south it is 0 here, so this will be 10, 20, 30, and 35 is in here. So we have to place a point here, that is south 35 west. After that, we have to draw a line to indicate the dip direction with the marking as TD, which indicates it is the true dip direction. Is that clear? So after marking the true dip direction, what we have to do is we have to plot the strike direction with the help of a protractor. We can use it here, and you know the relation between the strike and dip is 90 degree. So adding 90 from 35 will be 125. So we will be placing a point here, right? And we have to draw a line which will be indicating your first strike. Is that clear? So with the strike we have to draw the next strike, and as you know the horizontal equivalent we don't know for the next strike. For that we have to do some calculation, which is a dip is equal to strike interval by horizontal equivalent of the scale, and the question itself they had given the dip amount, which is 2 degrees 6 minutes, right? So we have to replace the equation and we have to solve it, and at the end we will getting 6.9 centimeter, which is the horizontal equivalent. So from point P we have to place a point at 6.9 centimeter, which will be somewhere here, and we have to draw a parallel line for the primary strike. Okay, is that clear? So in this map we will be getting only two strikes, and for the value, you know, here is an outcrop which is having a contour and a strike. So when there is an outcrop and there is a contour with the 450 degree 450 meter, then the strike will be equal to that, that is 450 meter, right? So this strike will be having a value of 450, and you know the true dip direction is this side. So as you move towards the true dip direction, the strike value will be reducing, and the strike interval, as you know, is 50 meter. So here it will be 400 meter. Is that clear? So in this map we will be getting only two strikes with the value of 450 and 400. So the next step is, as you know, we have to place the points of equal values. So here is a 450 meter strike and here is a 450 meter contour. You can keep a point here. And here is a 400 meter strike and the contour which meets here. And in this side it is not meeting. So we will be having only 1, 2 and 3 points. So all we have to do is we have to connect these 3 points, and that's it. So we'll start the line from here. So this will be first point and here will be second point. Then we will all the way turn around and we'll meet it here, right? So let us draw it, and that's it. This is how the outcrop is. So this is also the same way that is pointing upstream. So let us discuss about the topography. As you know, topography, it is in V-shaped contours and having a lowest value at the center. So this will be a valley with a regional trend of southwest. And the trend of the outcrop, in this case we can see according to V rule, as the dip and slope are in same direction, right? So here the slope is in south 35 west and the regional dip is south 35 west, and the regional slope is also in the same similar way. Okay, and V of the outcrop is pointing upstream. According to V rule, if this is the case, then the answer should be like slope should be higher than the dip. Is that clear? So we had discussed in our V rule. You just cross check if you want. So the V of the outcrop is pointing upstream, and we know the dip. So the slope should be higher than this 2 degrees 6 minutes, right? So for that we can go for the calculation to cross check the V rule. So we can do this with the help of the contour interval. Here the contour interval is say 50 meter, but for our convenience we will to take average value. So here I draw a line from 200 to 400. So the contour interval will be say here to here 50, 100, 150, 200. So this will be an averaging value. So I am just taking it as 200 as contour interval, and the horizontal equivalent will be the spacing between here to here, right? So just keeping it, slope is equal to contour interval by horizontal equivalent into scale, and the contour interval from this I took 200, and the horizontal equivalent from this will be say 3.8 centimeter, and I had converted the centimeter into meter. As you know, the contours are in meters, so I had to convert the centimeter scale into meter scale, which will be 0.038 meter. Okay, just by dividing it I will be getting a value of 0.2632, which is in terms of numbers, so I had to convert into degree. So as you know, tan theta, so tan inverse of 0.263 will be 14.74 degrees. So this is the slope angle in this region. As you know, the dip is in terms of some 2 to 3 degree, right? And the slope is higher than the dip, hence the B rule is proved here. And for this I will be completing the lecture here. We'll meet in the next class. Thank you.